Question 15. A code is made up of 2 letters of the English alphabet, lowercase, followed by 3 digits. Find the total number of codes possible when no letter may be used more than once, no digit may be used more than once, and no letter or digit may be used more than once. So first of all, it's important to note that find the total number. This is another way of saying how many. And when we're asked to find how many ways, we multiply. It's also important to note that in the English alphabet, there's 26 letters in total. And in digits, there are 10 digits in total. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 digits in total. So the code has 2 letters and 3 digits, which means it has 5 parts in total. So I've drawn 1, 2, 3, 4, 5 boxes. So that represents our code. So it has 2 letters, so I've done those in yellow, and it has 3 digits, I've done those in blue. So part 1, no letter may be used more than once. So that means no letter may be repeated. So there's 26 letters in total in the alphabet. So we start off with 26. We're asked to find the total number, which means how many, so we're going to multiply. And if we've used one of the letters already, let's say, for example, we used an S in the first box. So let's say we used S. Well, that means of the 26 letters that we had to choose from, we've now only 25 left to choose for the next box, because the S has been already used. And remember, no letter can be used more than once, no letter can be repeated. So it's going to be 26 multiplied by 25. Because remember, we've used a letter here already. So let's say the next letter we used was B. So this is an example of the start of a code that we could use. So next we move on to the digits. So part 1 said that no letter may be used more than once, but it didn't say anything about the digits. So presumably we can repeat digits if we want. So we're going to have 3 digits in here, and for the first digit we have a choice of 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. So we have a choice of 10 digits for the first one. So we're going to multiply by 10. And let's say that digit was 7. So then for the next digit, remember we can actually repeat numbers. So we could actually use that 7 again. So we have 10 to choose from again for the next digit. So we're going to multiply by 10. So let's say that the digit that we used was, in fact, 7 again. Then when we move on to choose for the last digit, remember, the digits can be repeated, so we still have 10 to choose from for the last digit. So let's say this worked out to be a 6. So we could have chosen any digit at all from 0 to 9. So that means we had 10 to choose from, so I'm going to multiply by 10 here again. So we started off with 26 choices for the first letter, and then we used one of the letters and we could not repeat that letter again. So then we only had 25 choices left for the second letter. We then moved on to the digits. We had a choice of 10 digits for the first digit. We were allowed to repeat the digits, so we actually had a choice of 10 digits for the next digit. And again, we had a choice of 10 digits for the last digit. So this is just an example of one of the codes that we could have used. So SB776, but you don't have to write this out. This is not part of the answer. This is just showing you one type of code we could use. What's important is how many types of codes could we get where no letter may be used more than once. So 26 times 25 times 10 times 10 times 10 gives us 650,000 different codes that we could have used. Question 2. So how many codes are possible if no digit may be used more than once now? So no digit. So it doesn't say anything about the letters, so presumably we can repeat the letters. So we're going to use the same boxes again. So we're going to have 2 letters and 3 digits. So remember, this time the digits cannot be repeated, but the letters can. So how many letters in the English alphabet? There's 26, so we start off with 26. Now remember, we're asked to find the total number, so that's really how many ways, so we multiply. So we're going to multiply 26. So for the first letter, we had a choice of 26 letters. And for the second letter, we also have a choice of 26 because remember the letters can be repeated. So you could have had AA or BB. So it's 26 times 26. And then we're going to multiply that by the number of digits we can choose from for the first digit. And there are 10 digits in our numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that makes 10 altogether. So we're going to multiply by 10. So then, what are we going to multiply that by? So now we're focusing in on the second of the digits. Now remember, the question said no digit may be used more than once, so no digit may be repeated. So let's say we'd chosen an 8 in the first box. Well, now we cannot choose 8 for the second box. So we're left with 9 digits to choose from. So it's going to be 10 multiplied by 9. And then what are we going to multiply that by? Well, we're now looking at our last digit. So remember, no digit may be used more than once. So whatever digit you chose for the first and second digits, you've used them now. So 10 digits, take away 2, leaves us with 8 digits to choose from for the last digit. So we're going to multiply by 8. And 26 by 26 by 10 by 9 by 8. And that gives us 486,720 ways we could make this code where no digit may be used more than once. So remember, no digit can be used more than once. It didn't say anything about the letters. So we had 26 choices for the very first letter. We could repeat a letter, so we had 26 choices for the second letter. For the digits, there are 10 digits in total, so we had 10 digits to choose from for the first digit. It said in the question, no digit may be used more than once, no digit may be repeated. So therefore, whatever digit we've used for the first digit, we can't use it for the second or the third one. So for the second digit, 10 minus 1 is 9. We're left with 9 choices for the second digit. And likewise, whatever digits we used for the first and the second digits, we cannot use them, we cannot repeat them for the third digit. So 10 minus 2 leaves us with 8 choices of digits for the last digit. So 26 by 26 by 10 by 9 by 8 is 486,720 ways we can create this code where no digit may be used more than once. Question 3. Find the total number of codes possible when no letter or digit may be used more than once. So in the first question, no letter could be used more than once, no letter could be repeated. In the second question, no digit could be used more than once, no digit could be repeated. In the third question, no letter or digit may be used more than once. No letter or digit may be repeated. So for the first letter, we start off with a choice of 26 letters because there's 26 letters in the alphabet. And the question says find the total number, which means how many, so we multiply. And we're going to multiply that by 25 because once we've used one of the letters here, it doesn't matter what the letter is, let's say it's a P. We've used the letter, we can't use it again, so now we've only 25 choices to choose from, 25 letters to choose from for the second letter. So we're going to multiply that 26 by 25. Now we move on to the digits. So for the first digit, we have a choice of 10 digits, so we're going to multiply by 10. Remember, we cannot use a letter or a digit more than once. We cannot repeat a letter or a digit. So let's say we used a 5 for the first digit. Well, we had a choice of 10 here. We've used one of them, so now we have a choice of 9 for the second digit. So we're going to multiply by 9. And then for our last digit, we've used 2 already. So maybe it was a 3 and a 4 we used. It doesn't matter what we used. We've used 2 already. So now we've 8 left. So 10 take away 2 leaves us with 8 digits to choose from for the last digit. So we're going to multiply by 8. And 26 by 25 by 10 by 9 by 8 gives us 468,000 ways we can create this code where no letter or no digit may be used more than once, where no letter, no digit may be repeated.